NASA is a popular space agency. However, lately the US agency has been focusing on a surprising part of the universe, not out into space, but underwater. Why is NASA studying the water and what has it discovered? Stay tuned as we bring you NASA's terrifying new underwater discoveries that change everything. The Hadal Zone refers to the deepest sections of the Earth's oceans and is named after Hades, the Greek deity of the underworld. The Hadal Zone is the ocean's deepest region, stretching from 6 kilometers (3.7 miles) to 11 kilometers (6.8 miles) below the surface. It is made up of deep pits and troughs caused by the collision of tectonic plates. The Hadal Zone encompasses an area of seabed the size of Australia, although more than 80% of it is undiscovered. NASA is working hard to fix that though, but why will this agency, whose core function is space exploration, focus on doing underwater research? The Hadal Zone is a hostile and severe environment with pressures exceeding 1,000 times that of the surface and temperatures approaching freezing. There is no sunlight and there is very little oxygen or nutrition. Despite these extreme conditions, the Hadal Zone supports a surprising variety of life forms, including fish, crabs, worms, and microorganisms. These species have evolved to survive in the dark and under extreme conditions by employing numerous tactics such as bioluminescence, chemosynthesis, and symbiosis. The Hadal Zone is also of scientific interest and study because it contains clues to the genesis and evolution of life on Earth and elsewhere. The Hadal Zone is regarded to be one of the planet's oldest and most stable habitats, and it may have served as a haven for life during previous mass extinctions. And it could also be similar to conditions on other ocean worlds in our solar system, such as Europa or Enceladus. And so scientists seek to learn more about the boundaries and potential of life in the universe by researching the Hadal Zone. The Hadal Zone is one of Earth's remaining frontiers and one of the most difficult to investigate. It necessitates cutting-edge technology and engineering as well as bravery and curiosity. The Hadal Zone is a realm of mystery and magic full of new discoveries. And so NASA, the US space agency, is studying the deep ocean in search of clues about what oceans on other worlds might look like, as well as pushing the boundaries of science and technology in one of our planet's most difficult environments. It's a mission full of awe, danger, and the non-significant threat of implosion. The objective is that the undersea discoveries they make will assist in solving some of space's mysteries while also testing some of the technology and experiments required for trips beyond the solar system. One of the key technologies that NASA is developing for this purpose is Orpheus, an autonomous underwater vehicle or AUV that can map the inaccessible depths of the Hadal Zone. Orpheus is named after the ancient Greek hero who journeyed to the underworld and back, and it is intended to be compact, lightweight, durable, and inexpensive. Orpheus, unlike most AUVs, employs very sensitive cameras to identify rock formations, shells, and other structures on the ocean floor to produce three-dimensional maps speckled with landmarks or possibly seabed marks. This optical navigation method is comparable to that used by NASA's Perseverance Mars rover to navigate the Martian landscape. Perseverance is equipped with a system of cameras that record photos of its surroundings and compare them to onboard maps in order to plan its route and avoid obstructions. Orpheus performs a similar function, but in a far more dynamic and unpredictable setting. Because the deep ocean changes continually due to currents, sedimentation, and biological activity, Orpheus must be able to react to these changes and update its maps accordingly. Orpheus must also contend with the difficulties of communication and electricity in the deep sea. Unlike Perseverance, which can interact with Earth via satellites, Orpheus cannot broadcast data or receive commands by radio waves or auditory transmissions. It must instead work autonomously, making decisions based on its sensors and algorithms. It must also save battery power, limiting its speed and endurance. Orpheus can only travel at around 0.5 meters per second or 1.1 miles per hour and can only stay on the surface for roughly 8 hours. Despite these constraints, though, Orpheus has already proven its capabilities in a number of field tests. It investigated an underwater canyon off the coast of Massachusetts in 2019, reaching depths of over 2 kilometers or 1.2 miles. And it entered an even deeper trench off the coast of Puerto Rico, reaching depths of nearly 5 kilometers or 3.1 miles. It captured high-resolution photographs and data in both situations, revealing new insights into the geology and biology of these places. Orpheus is part of the Subsea, or Systematic Underwater Biochemical Science and Investigation Analog Project, which combines space and ocean investigation. Subsea wants to investigate how deep ocean hydrothermal vents may be analogs for future habitats on distant worlds like Europa or Enceladus. NASA intends to send future expeditions to examine these frozen moons' underground oceans, which potentially harbor life. Subsea intends to contribute to the search for life beyond our planet by examining how life thrives in harsh settings on Earth. And Orpheus could possibly serve as a prototype for future AUVs that would investigate other ocean worlds in our solar system. NASA, for example, is working on Trident, a nuclear-powered AUV capable of melting through Europa's icy crust and exploring its ocean. Trident would employ Orpheus-like visual navigation technology, but with advanced capabilities such as artificial intelligence and machine learning. Orpheus is not just an engineering marvel, though, but also a tribute to the force of curiosity and discovery. Orpheus is paving the groundwork for future discoveries in outer space by going into the deepest oceans on planet Earth. Now, Subsea itself is a research program that intends to bring together the fields of ocean and space travel by investigating how deep ocean hydrothermal vents could be analogs for potential ecosystems on other worlds. Dr. Darlene Lim of NASA's Ames Research Center leads Subsea, which is financed by the NASA Planetary Science and Technology from Analog Research (PSTAR) program, with a major in-kind support from NOAA's Office of Ocean Exploration and Research. The initiative is a collaboration of government organizations, nonprofit organizations, and university research teams that support both Earth and space exploration, including NASA, NOAA, the Ocean Exploration Trust, and different academic centers. Subsea's primary goals are to 1. Investigate seabed hydrothermal systems in the context of simulated low-latency teleoperation or LLT mission, in which a distant science team connects with a field team via a time-delayed link. 2. Develop and test novel technology and techniques such as autonomous underwater vehicles, visual navigation systems, environmental DNA sensors, and chemical analyzers to enable science-driven exploration in severe environments. 3. Evaluate and improve operational ideas and workflows used to carry out LLT operations, such as data management, decision-making, communication protocols, and human aspects. 4. Understanding the geology, chemistry, and biology of hydrothermal vents, as well as how they relate to prospective homes on other ocean worlds like Europa and Enceladus. Subsea conducted 2 field operations in 2018 and 2019, exploring hydrothermal vents in the Pacific Ocean using the research vessel Nautilus and its remotely operated vehicles ROVs Hercules and Argus. The initial campaign concentrated on the Lo'ihi Seamount, an active undersea volcano about 30 kilometers or 19 miles off the coast of Hawaii. The Gorda Ridge, a mid-ocean ridge located about 120 kilometers or 75 miles off the coast of Oregon and California, was the focus of the second mission. Both locations are expected to be similar to those on other ocean worlds in our solar system. During these operations, the Nautilus field team used the ROVs to collect photographs, samples, and data from the sea floor. They spoke with a remote science team based at exploration command centers around the United States, including NASA's Ames Research Center and Jet Propulsion Laboratory. The communication link was meant to replicate a genuine time delay of up to 20 minutes, as is predicted for future Mars or Europa missions. Based on their scientific goals and interests, the remote science team guided and directed the field crew. The ROV data was also streamed live online via telepresence technology, enabling public outreach and education. Subsea's scientific findings have provided fresh insight into the geology and chemistry of hydrothermal vents, as well as the biological forms that inhabit them. Subsea discovered, for example, that the Lo'ihi Seamount has a rich microbial population that thrives on the hydrogen created by the volcanic activity. This discovery implies that hydrogen could be a major source of energy for life on other ocean worlds. Subsea also discovered a complex hydrothermal system at Gorda Ridge that fluctuates in temperature, pH, and chemical composition. This discovery suggests that hydrothermal vents may provide a variety of environmental niches for various creatures. Subsea's operational experiences have also aided in the improvement of methodologies and tools for executing LLT operations. Subsea, for example, created a data management system that enables a remote science team to view and interpret data from different sources in real time. During LLT missions, this technology allows for rapid data analysis and decision-making. Subsea also assessed communication protocols and human factors that influence field and remote team performance and satisfaction. This evaluation gives useful feedback for future LLT flights. Subsea is both a great scientific endeavor and a bold exploratory effort. Subsea is expanding our knowledge of both domains and preparing us for future discoveries in our solar system and beyond by bridging the gap between ocean and space study. Another shocking discovery made by NASA is the amount of water blasted into the Earth's stratosphere by the Tonga eruption. A massive volume of water vapor blasted into the atmosphere, as observed by NASA's microwave limb sounder, has the potential to temporarily warm the Earth's surface. When the Hunga Hapai volcano erupted, it triggered a tsunami that raced around the Earth and a sonic boom that circled the globe twice. The underwater explosion in the South Pacific Ocean also ejected a massive plume of water vapor into the stratosphere, enough to fill almost 58,000 Olympic-sized swimming pools. The sheer volume of water vapor could be enough to briefly change the global average temperature of the Earth. "We've never seen anything like it," said Louis Milan of NASA's Jet Propulsion Laboratory in Southern California. He supervised a new study that looked at how much water vapor the Tonga volcano pumped into the stratosphere. The stratosphere is the layer of the atmosphere between 8 and 33 miles, or 12 and 53 kilometers above the Earth's surface. Milan and his colleagues estimate that the Tonga eruption transported roughly 146 teragrams, or 141 trillion grams of water vapor into Earth's atmosphere, which is equal to 10% of the water already existing in that atmospheric layer. That's about 4 times the amount of water vapor that scientists believe the Mount Pinatubo eruption in the Philippines lofted into the stratosphere in 1991. Milan examined data from NASA's Aura satellite's microwave limb sounder MLS, which detects atmospheric gases such as water vapor and ozone. After the Tonga volcano erupted, the MLS team began to notice abnormally high levels of water vapor. "We had to carefully inspect all of the measurements in the plume to ensure they were reliable," Milan explained. Volcanic eruptions rarely release a large amount of water into the stratosphere. Only 2 earlier eruptions, the 2008 Casatochi event in Alaska and the 2015 Calbuco eruption in Chile, have transported significant amounts of water vapor to such high altitudes in the 18 years that NASA has been conducting research. But in comparison to the Tonga event, those 2 events were minor blips, and the water vapor from both earlier eruptions vanished swiftly. The extra water vapor injected by the Tonga volcano, on the other hand, might last for several years in the stratosphere, and this increased water vapor could affect atmospheric chemistry, accelerating specific chemical reactions that could temporarily worsen ozone layer depletion. It may also have an effect on surface temperatures. Massive volcanic eruptions such as Krakatoa and Mount Pinatubo are known to chill the Earth's surface by ejecting gases, dust, and ash that reflect sunlight back into space. The Tonga volcano, on the other hand, did not inject substantial amounts of aerosols into the stratosphere, and the massive amounts of water vapor produced by the eruption may have had a minor transitory warming effect, since water vapor retains heat. The effect would fade as the excess water vapor cycled out of the stratosphere, and it would not be significant enough to worsen climate change consequences. The sheer volume of water injected into the stratosphere was most likely only possible because the underwater volcano's caldera, a basin-shaped depression formed after magma erupts or drains from a shallow chamber beneath the volcano, was at just the right depth in the ocean, approximately 490 feet or 150 meters. There wouldn't have been enough seawater superheated by the erupting magma to account for the stratospheric water vapor values Milan and his colleagues observed if the volcano had been any shallower, and the huge forces in the ocean's depths could have muffled the explosion if it had gone any deeper. Now, because it detects natural microwave signals generated by Earth's atmosphere, the MLS device was well positioned to detect this water vapor plume. The ability to measure these signals allows MLS to see through impediments such as ash clouds, which can blind other devices sensing water vapor in the stratosphere. MLS was the only instrument with dense enough coverage to capture the water vapor plume as it happened, and it was also the only one that wasn't affected by the ash that the volcano released. JPL conceived and built the MLS instrument, which is operated by NASA by Caltech in Pasadena. The Aura mission is managed by NASA's Goddard Space Flight Center. These underwater projects serve as a foundation for NASA's even more ambitious projects like the Ocean World projects. The Ocean Worlds project at NASA is an ambitious effort to investigate the possible habitability of icy moons in our solar system and beyond. The project's goal is to investigate the conditions and mechanisms that enable or prevent biological activity in these worlds in order to better understand the origin, evolution, and distribution of life in the cosmos. The project includes a number of missions and devices that study various elements of ocean planets such as geology, chemistry, hydrology, and astrobiology. Among the primary missions and instruments are the Europa Clipper spacecraft that will orbit Jupiter and make numerous flybys of Europa, one of our solar system's most intriguing possibilities for life. Europa Clipper will study Europa's surface and subsurface, analyze its magnetic and gravitational fields, sample its thin atmosphere, and look for water vapor plumes erupting from its icy crust. Dragonfly, a rotorcraft lander that will investigate Titan, Saturn's biggest moon and another possible home for life. Dragonfly will fly to numerous sites on Titan's surface to collect data on its organic-rich environment, which mimics a primordial Earth. Enceladus Life Finder, a proposed expedition to fly through the plumes of Enceladus, Saturn's second ice moon with a vast ocean beneath its crust. Enceladus Life Finder would examine the plume material's composition and isotopic ratios for indicators of biological activity or habitability. Ice Giant Orbiter, a proposed mission to examine Uranus and Neptune, our solar system's ice giants, as well as their several moons and rings. The Ice Giant Orbiter would study the genesis and evolution of these planets and their satellites, as well as the possibility of underground oceans on these worlds. Ocean Worlds Explorer, a proposed mission idea in which a versatile spacecraft platform would be used to visit numerous ocean worlds in our solar system, including Pluto, Triton, Ceres, and others. The Ocean Worlds Explorer would characterize these bodies' geophysical, geochemical, and astrobiological features by remote sensing and in-situ studies. The Ocean Worlds project at NASA is a bold endeavor that aims to solve some of the most fundamental concerns about our location in the universe. It hopes to obtain new insights into the origins of life on Earth and the possibilities of life elsewhere by examining these enigmatic and fascinating places. And another landmark underwater project by NASA is the GRACE mission. In a first-of-its-kind study, scientists combined NASA's satellite images of Earth with data on human activities to map and explain where fresh water is changing around the world. According to the study, which was published in the journal Nature, Earth's wetland areas are becoming wetter and dry land parts are becoming drier due to a range of reasons such as human water management, climate change, and natural cycles. Matt Rodell of NASA's Goddard Space Flight Center in Greenbelt, Maryland, led a team that used 14 years of measurements from the US-German-led Gravity Recovery and Climate Experiment, shortened to GRACE, spacecraft mission to study worldwide trends in fresh water in 34 places around the world. They also had to pull satellite precipitation data from the Global Precipitation Climatology Project, NASA U.S. Geological Survey Landsat imagery, irrigation maps, and published reports of human activities related to agriculture, mining, and reservoir operations to understand why these trends emerged. Only by analyzing the linked datasets were the scientists able to gain a complete picture of the causes and magnitudes of Earth's freshwater changes. This was the first time scientists used observations from multiple satellites to conduct a comprehensive assessment of how freshwater availability is changing across the globe. A key goal was to differentiate shifts in terrestrial water storage caused by natural variability, for example, wet and dry periods associated with El Niño and La Niña, from trends related to climate change or human impacts. such as pumping groundwater out of an aquifer faster than it's replenished. Lakes, rivers, soil, snow, groundwater, and ice all contain fresh water. Now, the loss of fresh water from the poles due to climate change has ramifications for sea level rise. Fresh water is one of the most important resources on land used for drinking water and agriculture. While water supplies in certain areas have remained largely consistent, others have seen increases or losses. What we are witnessing today is a major hydrologic change. Scientists see a distinct pattern of the world's wetland areas becoming wetter, those at the high latitudes and the tropics, and the dry areas becoming drier. And multiple hotspots caused by groundwater depletion are embedded within these dry zones. While water loss in some locations, such as melting ice sheets and alpine glaciers, is obviously caused by warmer climates, determining the driving mechanisms behind other patterns of freshwater change needed more time and data. And this pattern of wet getting wetter and the dry getting drier during the rest of the 21st century is predicted by the Intergovernmental Panel on Climate Change Models. But researchers needed a much longer data set to be able to definitively say whether climate change is responsible for the emergence of any similar pattern in the GRACE data. The twin GRACE satellites were launched as part of a collaborative effort with the German aerospace center DLR to detect changes in the Earth's gravitational field produced by mass movements on the planet below. GRACE used this strategy to track monthly changes in terrestrial water storage. The team of researchers examined information on precipitation, agriculture, and groundwater pumping to find a possible explanation for the trends estimated by GRACE. For example, while pumping groundwater for agricultural purposes contributes significantly to global freshwater depletion, groundwater levels are also sensitive to cycles of protracted drought or rainy circumstances. Such a combination was most likely responsible for the severe groundwater depletion recorded in California's Central Valley from 2007 to 2015, when lower groundwater replenishment from rain and snowfall combined with increased pumping for agriculture. During the same time period, southwestern California lost 4 gigatons of fresh water every year. A gigaton of water is enough to fill 400,000 Olympic-sized swimming pools. The majority of California's fresh water comes from rainfall and snow accumulation in the Sierra Nevada snowpack, which is subsequently regulated as it melts into surface waterways via a network of reservoirs. People depended more heavily on groundwater when natural cycles resulted in less precipitation and less snowpack, and therefore less surface waters. And fresh water declines in Saudi Arabia are also partly a result of agricultural pressures. From 2002 to 2016, the region lost 6.1 gigatons of stored groundwater every year. Landsat satellite imagery indicates an explosion of irrigated farmland in the dry environment from 1987 to the present, which could explain the increased drawdown. The team's investigations also revealed huge decade-long patterns in terrestrial freshwater storage that do not appear to be caused by human activity. Natural cycles of high and low rainfall can generate a trend that is unlikely to last. Africa's western Zambezi Basin and Okavango Delta, a critical watering source for wildlife in northern Botswana, are 2 examples. During a 14 years period, water storage in this region rose at a pace of 29 gigatons per year on average. This wet spell during the GRACE mission came after at least 2 decades of drought. This is a result of natural fluctuation that occurs throughout time in this African region. But the researchers also discovered that in some areas a mix of natural and human influences might result in complex circumstances. Xinjiang province in northwestern China, roughly the size of Kansas, is bounded to the west by Kazakhstan and to the south by the Taklamakan Desert, and it includes the central portion of the Tian Shan Mountains. Previously unrecorded water losses occurred in Xinjiang throughout the first decades of this century. The team of scientists put together a number of elements to explain the loss of 5.5 gigatons of terrestrial water storage in Xinjiang province per year. The cause was not less rainfall. Climate change-induced glacier melt and groundwater pumping from coal mines were also contributing to surface water additions. However, these inflows were more than offset by depletions induced by an increase in irrigated farmland water use and evaporation of river water from the desert bottom. GRACE Follow-On or GRACE FO, a collaborative mission with the German Research Center for Geosciences GFZ, was scheduled to launch after. This mission will investigate variations in the amount and distribution of water on the planet. Although it appears to be a straightforward process, noticing these changes requires precision to measure distance shifts 100 times smaller than a human hair. And monitoring the Earth's water cycle is not just one of the most critical topics in modern climate research, but it's also one of the top 5 greatest priorities mentioned in the National Academies of Sciences, Engineering and Medicine's 2017 to 2027 Decadal Survey, Thriving on Our Changing Planet. GRACE FO, as the heir to that tradition, will continue to conduct parallel investigations of Earth's climate and gravity. It will use a similar setup, a pair of satellites with extremely accurate distance tracking. GRACE FO, however, will come with an astounding, game-changing update. Unlike the original GRACE mission, which employed a microwave sensor to measure the distance between the 2 satellites, GRACE FO will also include a laser ranging interferometer (LRI), the first active ranging laser in orbit. A successful LRI on GRACE FO would pave the way for future laser interferometry missions, such as ESA, NASA's Laser Interferometer in Space Antenna (LISA), which will hopefully use a similar technology to study gravitational waves.